welcome to CEC lectures. Myself Dr. Priti Jagwani. I am from Department of Computer Science, Aribhat College, University of Delhi. So, in this series of computer networks, we have looked into the model of communication, which is ISO OSI model, and today we will be finishing this particular topic along with whatever is left in this OSI model. So, let me give you a quick recap of how this data flows in OSI model that we have covered in the last lecture, but today we are going to get it into kind of a step by step manner. So, when we talk about OSI model, you all are aware that that is basically a kind of an abstract model which governs the, or which we can say direct the communication between two machines on a network or two nodes on a network. So, when we say we are going to transfer information from one particular device to another, it is going to travel through the 7 layers of OSI model. So, from the sender, if we talk about, so first the data travels down through the 7 layers of the sender's machine, and then on the next, which is on the receiving end, the data climb back those 7 layers on the in the at the receiver's end. So, when we say how this process happens in a step by step manner, so these 7 layers are application layer. So, application layer is the layer which actually creates the data. Then comes presentation layer. The basic function of presentation layer is formatting the data and encryption formatting, in which the data is kind of accepted. That means it could be any kind of format, it could be changing of the format from ASCII to ABCDIC and so on and so forth, and also encryption on encryption of the data is the function of this presentation layer. Below that we have session layer. This session layer is there to manage and establish various communications. Below that we have transport layer, which is there to break the data into different segments, and the basic function or the kind of main agenda here is to ensure a reliable delivery of the data. Then comes network layer, in which the segments which are given from by the transport layer are packaged into different packets, and then the main function here is the routing of those packets on the best of the routes, we can say. Then comes data link layer, in which packets are framed and data is sent on to the next device. So, from segments to packets and from packets to frames, and then at the final physical layer, which is at the kind of we can say the lowermost layer or the bottommost layer, the physical layer, in which the frames are converted into bits and then transmitted physically. Now, let us say if we want to look this whole kind of thing with the help of pictures. So, see what is happening. So, here we have two devices, one is device A, another one is device B. So, device A is the sender, obviously device B is the receiver, and see what is happening at each and every layer, how this encapsulation is happening at the sender's end and how this de-encapsulation is happening at the receiver's end, that we are going to make clear with the help of this figure. So, initially we have an application layer which is going to kind of we can say create the data, or which is going to I can say start the data, or the functionality starts from here. So, we have a data here. Now, coming on to the next lower layer, which is the presentation layer. Now, if you can see on the screen, now a PH, which is nothing but the presentation header, is being attached to that original data. So, now that original data is kind of we can say extended by providing the presentation header onto that data, and this is being done by the presentation layer. Moving further, if we go deeper down, we have session layer. Now, session layer is there. This session layer is going to insert more information in the form of HTTP header onto this particular we can say data and presentation header. So, you can see in the form of stairs, this data is actually getting into the bundles, getting encapsulated with every layer. Moving further, if we go more down, we have transport layer. Transport layer job is to ensure this reliable delivery, and for this it is going to include a TCP header onto the data. Now, the data which was started from the application layer becomes data and presentation header onto the presentation layer. On the next layer, which is the session layer, HTTP header has been enclosed. Then on the transport layer, within that HTTP header, PH and data, above that one TCP header has also been kind of enclosed. Now, coming back to the lower layer, we have network layer. Now, the job of network layer is to kind of we can say again put some information in the form of IP header. So, now data has become kind of data, then presentation header, then HTTP header is there, then we have TCP header followed by IP header. Then the next, which is the second last layer, data link layer. That data link layer is actually going to kind of include one MAC header, because this this data link layer deals in the kind of MAC addresses of the machines. So, data followed by kind of data along with presentation here header with HTTP header, then we have TCP header, then we have IP header, and finally, the MAC header has been kind of enclosed along with the data by the data link layer. So, this is kind of we can say a complete set of data. Now, if this is the complete set of data, then what is the role of your application layer? Application layer is going to convert this whole data into in the form of you can say physical bits, and now these physical bits are going to travel from device A to device B with the help of media, whatever media you choose. And now in this way your device A or all the layers of the device A are going to work. Moving on to the device B. Now, what is happening at device B? Let us see that with the help of an figure here. So, here at the device B, the data is kind of dealt with from bottom to top. At the sender's end, the data has been dealt with from top to bottom, but here it is going to climb up the hierarchy, we can say. So, physical layer has got all those physical bits which are given by your physical layer of device A. So, all those bits or all those data in the form of bits is going to be taken up by the physical layer of device B. Then this data is now we can say it can be seen at the data link layer. This is seen in the form of MAC header. Then we have IP header, then we have TCP header, then we have HTTP header, presentation header, and the data. Now, in these layers de-encapsulation is actually happening. So, moving further on the top layer of data link layer, which is the network layer, that that MAC header we can say is being kind of stripped off by data link layer of the device B, which is the receiver device, and this MAC header was inserted by the data link layer of device A, which was the sender's device. So, kind of you can say an opposite kind of function, or related even we can say that kind of function is being performed by the same layers of sender and the receiver. Then at the network layer, MAC header has been already removed. Then at the network layer, IP header is no more required, because that information has been kind of we can say consumed. Then on top of it, at the transport layer, the data which is available is TCP header, HTTP header, presentation header, and the data itself. Moving further, this TCP header is also kind of we can say stripped off, removed, or we can say the more technical language here is going to be that it is being consumed of, or it is being used of. Then similar thing happens with the HTTP header on this session layer. that HTTP header after that is not required. At the presentation layer, the data is there along with the presentation header only. That also will stripped off in case of the topmost layer, which is the application layer, and at the application layer of device B, only the data which was created by the application layer of device A is going to be there. So, while sending, the information is being kind of attached, it is we can say encapsulated, while receiving all the layers do the opposite functionality, and the whole decapsulation is kind of take place from the data link layer, or even we can say from physical layer to the application layer, and in this way your whole data communication between the two devices which are there in order to communicate the data takes place. Now, we have seen this data flow with the help of an figure. Now, if we want to look that with the help of a textual example, let us say for example, the application which we are assuming here is an email, and person A wants to send an email to person B. Then person A is going to create that email with the help of an interaction with any of the email applications. It could be Gmail, Outlook, or Hotmail, or any other. Person is going to write his email which is to be sent, and this is actually happening at the, we can say, application layer. Now, when this data created, which is in the form of email in this example, is being kind of given to the presentation layer. So, mail application has prepared the data, has prepared the email, and at the presentation layer this mail application prepares for data transmission, like encryption of data and formatting it for the data transmission if it is even required. Then moving on further, if we talk about the session layer, then session layer is there to establish the communication. So, there is a connection establishment between the sender and receivers onto the internet, and the idea or the basic agenda is to send that email from the sender to the receiver. Now, the data has been created, the data has been we can say formatted in the form in which it is to be presented, or in which it is to be sent. Then a session, or we can say a communication, has also been established. This is done by the topmost 3 layers. Moving further, at transport layer, what happens, this email data is being broken into smaller segments. The name of the we can say the data piece here is the segment, and in order to perform the error checking and to maintain the reliability of the information, sequence number is being kind of we can say added to these segments, so that even if a segment is missing, that can be identified by saying that so this particular sequence number is missing, or even if kind of 2 is arriving before 1, then at the assembling and at the receiving end, that 2 has to wait for 1 to arrive, and then 1, then after 2 is going to be assembled. So, these sequence number are important in order to maintain the sequence, and also in help in error checking, help in maintaining the error checking information, and thus they are kind of maintaining the reliability of the whole information which is being sent from one end to another end. Moving further down at network layer, if we talk about the addressing of packets is done in order to find the best routes for transfer, because the job here is to kind of we can say route the packets. So, whichever best route is given for the packets, that through that particular route your packets, or you can say your data, is being sent, and that data is now in the form of packets. Now, in the next step at the data link layer, these packets are encapsulated in the form of frames, and then the kind of local address of the machine, which is the MAC address, is added for all those local devices which are available on a network, and at the local level it also checks for errors using various error detection mechanisms like parity bits and so on and so forth. At finally at the senders end, there comes the physical layer. So, physical layer frames are transmitted in the form of electricals or optical signals over a physical network medium, whatever media if you are going to choose, like Ethernet cable or Wi-Fi. So, at the sender's end, the email which was being created is now after getting ready for the presentation, after getting ready for the session and routing and data kind of getting into frames and so on and so forth. Now, your whole data, your whole email is in the form of we can say bits or simple your optical signals. Now, in the form of these optical signals or bits, your email is now reached to the receiver, which is your let us say person B. Now, this whole process will reverse. So, the encryption will now changed into the decryption, where the frames were kind of we can say frames were created, frames were encapsulated, or the receiving end frames are going to be de-encapsulated and so on and so forth. The whole process will get reversed, and at last the email will be shown on the person's B's email client, which is kind of we can say the application layer at the senders at the receiver's end. Now, with this whole idea of OSI model, including our previous lectures, we have looked into what all are the layers, what are the functionalities. Then we have graphically also tried to understand that how this data is being communicated. Also, we have seen an example of this particular data being how this data is being transferred. Now, coming to the other characteristics, advantages and disadvantages of OSI model, let us try to explore the other nuances also. So, if we talk about advantages of OSI model, it is basically we can say it defines the whole data flow or whole communication flow of a computing system in the form of 7 different layers, fine. So, because of this division of this communication system or this communication process into 7 layers, it is easier to it is easier for a user to understand and to troubleshoot this also. So, for example, if there is a kind of we can say problem with the format of the data, then we can troubleshoot the layer which is responsible for the format, and that is nothing but the presentation layer. If it is kind of related to routing, then we can look at the network layer. So, this bifurcation is going to make the whole task easier to understand and the troubleshoot also. This OSI model standardizes the network communication because each layer is having a fixed function, a fixed set of protocols which is going to be followed for that particular functionality. And because of all these we can say compartmentalization, diagnosing of network problem has become easier with this OSI model. As I was talking about, troubleshooting is easier, and also it is easier to improve with advancements as each layer can get the updates separately. So, this kind of we can say encapsulation or abstraction is going to help us in advancements also. Looking into the disadvantages of OSI model, this OSI model with this 7 layers is actually we cannot say it is very easy to understand. It is a relatively complicated thing and hard for beginners to understand. And in real life networking, if we talk about the real life networking applications are going to rely on or going to use a simpler model, which is the TCP IP model, and this is also known as Internet Protocol Suite. And because of this, OSI model is not always directly applicable. So, this is one of the disadvantages. But yes, for the kind of we can say understanding point of view that how these functions are going to happen, this could be a useful tool, but not applicable in real life scenarios, because in real life scenarios internet protocol suite, which is TCP IP model, is going to be kind of, we can say, more prominently, or prominently we can say used. We will be looking into this TCP IP model and its different layers and functions in our upcoming lectures as well. Then another disadvantage of this OSI model is each layer in the OSI model is going to add some rules, some operations, some functionalities. So, the whole system is becoming kind of, we can say, pretty time consuming, and this whole addition is going to make the whole model less efficient. And also, as I have told you, that in real life applications we are using this TCP IP model more. So, this OSI model has become more of a we can say theoretical framework, although as I have told you that it is very great for understanding the concept, but it is not always practical for implementation because of its number of layers. 7 layers as far as a communication system is concerned is kind of, we can say, a little more. So, what are the protocols used on all those kinds of OSI layers is also something which is very important. So, that we need to kind of look into in a consolidated manner. So, at the physical layers we have SONETs and DH protocols, USB protocol. The data is in the form of bits, and working, you all are aware that it is it establishes the physical connection between the devices. At the data link layer, the protocols which are there are kind of Ethernet and PPP. The data is in the form of frames, and function of, or major function of data link layer is to ensure node to node delivery of messages. Moving further, network layer, we have transmission of data from one host to another, which is located in different networks. Data is in the form of packets. Protocols which are important are ICMP, IGMP, OSFPF and IP protocol also. Transport layer is dealing with connection oriented, connectionless both the services. So, TCP is there and obviously UDP is there, and SCTP is also there in the form of protocols. Data is now arranged in the form of segments, and the idea is to take services from network layer and provide the services to the top layer, which is the application layer. Now, the session layer is going to establish connection, maintenance and ensure the authentication and ensures the security also, and for all these kind of tasks, the protocol which is being used is NetBIOS, RPC and PPTP. Now, the data is, you can say, in the form of segments, or simply we can say data. On top of it, we have presentation layer, which is the data from the application layer is going to be extracted by presentation layer, manipulated in the required format, and the protocols which are going to be used are MIME protocol, MIME. Then we have TLS or secured socket layer, SSL, because security is the kind of main task here. Moving further, we have application layer. It helps in direct interaction with the client and synchronizing the communication. The protocols depends on the applications which are going to use. It could be FTP if you are using the email application, it could be SMTP, or it could be DHCP or DNS. So, in this way we have we can say covered the whole OSI model, which was developed by ISO, International Organization for Standardization, in 1984. We have also looked into all these 7 layers and how these 7 layers work independently independent to each other. Then in our upcoming lectures, we will be looking into what are the alternatives which are available for this OSI model, or is there is this the only model to understand the communication? Obviously no, there are alternatives available to it, and within those alternatives we will be diving deep into your internet protocol suite, which is TCP/IP model. So in this lecture we are wrapping up our whole OSI model by covering all the nuances of that model. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next with the TCP/IP model. Till then, take care. Goodbye.